Okay, so this is section multiplying and dividing radical expressions. We're going to work with 4 different objectives: multiplying radical expressions, rationalizing denominators with one radical term, rationalizing denominators with binomials involving radicals, and writing radical expressions in lowest terms. We have not covered this in class yet, so you probably will not see this until next week, but I'm going ahead and recording it now, and then I will post it. I just won't have it published until after we go through it in class together. So here's objective 1. We're going to multiply radical expressions. The distributive property may be used when multiplying radical expressions. And you can see here that we would distribute the square root of 5 to both parts. And then you can multiply within because they both have a square root. But then you have to have the radical left here because the 2 is not sharing a radical. All right, and then don't forget, if you can simplify, you want to simplify. Remember here, if we're using, when we multiply binomial expressions, we still want to use foiling even with radicals. So let's do a couple of these. So we're going to distribute the square root of 10. So we will have 4 square root of 10 and that's going to stay like that. Then we also have square root of 10 times square root of 7. That's going to become 4 square root of 10 plus square root of 10 times 7, which is 4 square root of 10 plus square root of 70. And we're done there. Okay. Next one, we're going to take the 3 in. So we will have 3 square root of 20 minus 3 square root of 45. I'll write that a little bit neater. And what you need to realize with the square roots here is that we have some perfect squares within them. So for instance, in 20, that's made up of 4 times 5. So 2 squared times 5 minus 3. And we have 3 squared, which is 9 times 5. The radicals are going to end up matching. So 3 times 2, square root of 5, minus 3 times 3, square root of 5. So we get 6 square root of 5 minus 9 square root of 5, which is 6 minus 9 square root of 5. And that becomes negative 3. Negative 3 square root of 5. This is B. This was A. Okay. And we will obviously cover this in class this coming Monday, but if you have any questions, you can, hopefully you ask them in class. If not, feel free to email me because your test is this coming Wednesday. All right, so now we're going to use the FOIL method. Remember, that's first, outer, inner, and last. And sometimes when you draw it correctly, it'll make like a little smiley face. So I actually need to get rid of these so that I can see what's going on. So I'm going to do 8 times 9. And then I'm going to do minus 8 square root of 2 minus 9 square root of 5 plus square root of 5 times square root of 2. It's going to give us 72 minus 8 square root of 2 minus 9 square root of 5 plus square root of 10. and nothing else actually adds or subtracts together, so we are done there. Okay, so next we have actually something called conjugates, which is when we have the same binomial with two different signs in it. And what you're going to see is that we're actually going to be able to cancel a couple things out, the inside terms. So 7 times 7 under the square root is actually 7 squared. So we're just going to get 7 out, but we'll leave it like that. And then plus square root of 7 times 5 minus square root of 7 times 5. You can see those are going to cancel as long as I write them normal, not like hieroglyphics. And then minus square root of 5 times 5. So then these actually cancel. And then we have 7 minus 5, which gives us an answer of 2. Okay, here we have to rewrite this as the square root of 15 minus 4 times the square root of 15 minus 4. We will have to FOIL, so we're looking at the square root of 15 squared minus 4 square root of 15 minus 4 square root of 15 plus 4 squared. So that's going to be 15 minus 8 square root of 15 plus 16. So then we have to combine these two. We end up with 31 minus 8 square root of 15. Okay. What's nice here is we have conjugates again. So 8 times 8 gives us 8 squared. The inside terms are actually going to cancel. So plus 8 cubed root of 5 minus 8 cubed root of 5. And then minus cubed root of 5 squared. So again, these cancel. We end up with 8 squared is 64 minus the cubed root of 25. Right, and then E. Notice here that they give us this condition. We need to keep that in mind, and we should really rewrite it in our answer. But we will have the square root of m squared, which is going to be m. I'm going to try and reduce it as I go. Minus the square root of mn plus the square root of mn. So those are actually going to cancel. Minus the square root of n squared, so minus n. And we should say that m is greater than 0 and n is greater than 0. Not so much for the answer, but for the original, what we were given. It's just kind of good to keep that like that. Okay, so rationalizing the denominator, the process of removing radicals from a denominator so that the denominator contains only rational numbers is called rationalizing the denominator. This is done by multiplying by a form of 1. So what you can see here is that they showed, okay, if we have 1 divided by the square root of 2, we have this decimal. If we do the square root of 2 over 2, we have the same decimal. Someone decided at some point that we should not have radicals on the bottom of the fraction, and that's fine. So this is just the process that we have to do to make sure that we can do that. So I will be right back with you after I pull up the next Jamboard. Okay, so what we're going to do now is some more we're going to actually practice rationalizing the denominator. So for a here, we have 8 divided by the square root of 13. What we're going to do is multiply top and bottom by the square root of 13. When I was taught this, I was always taught to kind of think of it as kind of like a shoe method or a boot method. If you have that idea there, and plus the square root of 13 over the square root of 13 is multiplying by a version of 1, and then you're doing the right thing. What ends up happening is we get 8 times the square root of 13 over, really what's going on here is the square root of 13 squared, which is just 8 over the square root of 13 divided by 13. And that's the steps that we take. So let's do it for B. So here we do have a radical in the top and a radical in the bottom. What we care about is getting the radical out of the bottom. So we are going to multiply again by the radical on the top and bottom. And again, it's making that L or boot shape. But what's going to happen here is we're going to have 9 times 7 times 3 underneath the radical, and then the 3 squared underneath the radical on the bottom. Now, some of you would probably try to reduce this here. You can't because of the square root. So you can, though, when you do the square root portion correctly. So then this reduces to 3. So you end up with 3 square root of 21 as your answer. Let's make that a little bit wider so you can see that's a 21. Okay, last one here. C is negative 10 over the square root of 20. We're going to multiply top and bottom by the square root of 20. We're going to end up getting negative 10 square root of 20 over square root of 20 squared. And then we get negative 10 square root of 20 over 20. What we also need to realize is that the square root of 20 can be broken apart here. So that's going to be negative 10 square root of 4 times 5, which is 2 squared times 5 over 20. So negative 10, we're going to bring out 2 times 2 square root of 5 over 20. The 20 and the negative 10 times 2 are going to cancel. And we're going to be left with negative square root of 5 as our answer there. So these cancel. Or reduce, rather, if you look at it that way. All right, so what we have to do here is we have, if we use our quotient rule, we have negative square root of 27 over negative, or over 80. 80 So it's all in kind of how you want to see things. I like to simplify first. So I would change this to be negative square root of 3 squared, which is 9 times 3. It gives us the 27 over 80 times 80 is 16 times 5, so 4 squared times 5, and that will give us a 3 on the outside, a 3 on the inside, and then a 4 on the outside and a 5 on the inside. We're going to multiply top and bottom by just the square root of 5, because again, that gives us that boot shape. And then we're just going to end up multiplying the bottom by the 4. So that gives us negative 3 square root of 3 times 5. And then 4 divided by 5 times, or 5 squared. So that gives me negative 3 square root of 15 on top. And then 4 times 5 on the bottom, which is -3 square root of 15 over 20. That was A. B, we're going to take, and again, we'll fill that in at the end, but we would have the square root of 48. And let's just think about what's in 48. 48 is, let's see, we have 1 and 48, 2 and 24, 3 and 16. 16 is 4 squared, so times 3. And then we have 8 squared. That's 2, 4, 6, 8. So we can pull out a 4 and 1, 2, 3, 4 x's over square root of y squared times y. So we'll bring out 1y and leave a y. So you're looking at 4x to the 4th square root of 3 over y square root of y. We can't have the y left on the bottom there. So, or the square root of y there. So we need to multiply top and bottom by square root of y. So we get 4x to the 4th. 3 times y, so square root of 3y. And then just y times the square root of y squared, which will be 4x to the 4th square root of 3y over y times y, which is 4x to the 4th, square root of 3y over y squared. Okay, so some extra steps there that you probably all don't need to take, but definitely if some of you need it, I'd rather have it than not have it. All right. Okay. Okay. So cubed root of 8 on top, cubed root of 81 on the bottom. That's going to simplify to 2 over the cubed root of 9 times the cubed root of 9. And there's a reason why we're doing it this way. So if you can see, cubed root of 9 times cubed root of 9 will give us cubed root of 81. But here's the cool thing. If we multiply top and bottom by the cubed root of 9 again, then what we end up getting is 2 cubed root of 9, which doesn't simplify at all. But then we would have the cubed root of 9 times 9 times 9, or 9 cubed. So the cubes cancel, and we end up with 2 cubed root of 9 over 9. And that's why we did that. Okay, again, we want to pay attention that they gave us that. So then we can use the quotient rule and do the 4th root of 7x over the 4th root of y. So you want to ask yourself kind of like, what are we missing to get to that root? Well, in this case, we're missing 3 more. So y cubed, we're missing 3 more in the exponent spot. Just like we did up here, we had 9 to the 1st, 9 squared, 9 times 9 is 9 squared, and then times 9 again is 9 cubed. So you're doing the same thing down here. So we want to multiply top and bottom by the 4th root of y cubed, and that's going to end up eliminating the radical on the bottom. So we're going to multiply the top and get 4y cubed x over the 4th root of y to the 4th. which is the fourth root of 7y cubed x over y. And if you wrote that a little bit different, if you put the x first, that's fine. Put the y first, doesn't matter. As long as it's underneath that radical, you are good to go. All right. Rationalizing denominators with binomials involving radicals, what we're going to end up using is the conjugate. So it's the product of the conjugate. So here, and what happens is we end up eliminating the middle term, which helps us get rid of the radical portion. So let's take a look at some of these. This is just explaining a little bit more about conjugates in general. X plus y and x minus y are conjugates. So specifically, if x and y represent non-negative rational numbers, the product becomes x minus y. Whatever a radical expression has a sum or difference with square roots radicals in the denominator, rationalize the denominator by multiplying both the numerator and denominator by the conjugate of the denominator. So we're going to do these. So we have 4 over 1 plus the square root of 3. So the question you want to ask yourself is, what is the conjugate? And that's going to be 1 minus the square root of 3 then. Stop it. So you're going to take top and bottom, make that boot again. So on the top, you're just going to distribute, but I'll write it out. So it'll be 4 times 1 minus square root of 3 over the multiplication of the conjugate. And once you guys do this for a while, you're going to start seeing little patterns, so you won't have to always do every single step. But for the moment, this is what we're doing. And then you really should FOIL. So you would get 1 plus the square root of 3 minus the square root of 3 minus the square root of 3 squared. So that gives us 4 minus 4 square root of 3 over the middle terms cancel. So we get 1 minus 3, which is a negative 2. Everything can be reduced by 2. So divide by 2, divide by 2, divide by 2. And we end up with negative 2 plus 2 square root of 3. It's kind of written there a little bit small. Let me see if I can. Oh, I can move this a little. Oh, can I move the whole thing? Might help us if I can move the whole thing just a little bit. There, perfect, nice. So then here we get negative 2 plus 2 square root of 3. Okay, that is a bit squeezed, so we may end up needing to do a couple of our problems on a different page. I'm not sure. I'm gonna try to get it all in here for you, but we will see. Let me see if the next page is the same. So the next page is not the same, but it does provide us some room to write, so I might just carry on over there. So we would have 4 over 5 minus square root of 7. I'm not going to do all the steps this time to try and save us some space. Make sure if you need to know what's going on that you ask. That's going to give us 5 squared, which is 25, minus 7, which will give us 9. Nope, 18. So 25 minus 7 gives us the 18. And then everything can be reduced by 2. So divide by 2, divide by 2, divide by 2. This will give us a negative 2 here, a 2 here. And this is going to give us a 10 and a 2 and a 9. Which means we can still pull out a 2 in the top. So that's going to be 2, 5 plus square root of 7 over 9. Okay. All right, so 3 is, or C is the square root of 3 plus the square root of 7 over the square root of 5 minus the square root of 2. We have to multiply by the conjugate of the denominator. So not the numerator, the denominator. And then that makes this a little bit gross, but we can still do it. So we have to FOIL both pieces. We get 3 times 5 will give us the square root of 15, plus 3 times, or 7 times 5 will give us the square root of 35, plus the square root of 7 times square root of 2 will give us square root of 14. And then the last one is the square root of 3 times the square root of 2, which is the square root of 6. That all stays. And then the square root of 5 squared gives us 25 minus 2. So underneath it gives us square root of 25 minus square root of 4, which will give us 5 minus 2. So that's a 3 on the bottom. Okay. And then again, with this one, you want to pay attention to right there. They're giving you that. You might have to come up with that in some of these problems. So I'm going to try to squeeze in right here and do the write-up of the conjugate. So that's going to give us 8 8 square root of 3x minus y square root of y over, and what you need to realize is that the middle terms cancel out, the square roots drop, so it just ends up being 3x minus y. And we actually don't need to distribute. We can just leave it like that. It looks a lot nicer than if we were to try and distribute it. So really nice problem there for D. Right. Getting pretty close to the end of section 7.5. Then we'll move on to 7.7 and the one objective from 8.2, and then I'll move on to your review. All right, so we are going to write radical quotients in lowest terms. So remember, if there's a radical on the bottom, we will have to go back to rationalizing the denominator. We want to make sure that we can factor the numerator and denominator if possible, and then divide out any common terms. So again, we're factoring and then dividing out the common factor. So these are actually the last two questions in the lesson. So let's take a look at everything. 15, 6, and 18. Excuse me. We have a GCF equal to 3, which means we can divide each of these by 3. And you don't have to worry about the radical. That stays there. It's not going to be affected. So we would end up having 5 minus 2 square root of 2 over 6. And that can't be reduced anymore. So you're done there. Again, you might have to come up with these sometimes, so make sure that you know how to do that. First thing we're going to do is simplify this radical because it is not in simplest form. So we'd have 15k outside still plus square root of 25 times 5 times k squared. We're going to pull out a 5 and a k. We should really write this as the correct thing. Give me 1 second, guys. This needed to be written as 5 squared times 2 times k squared, not times the 5, all over 20k. We're going to pull out a 5 and a k, so it'll be 15k plus 5k times the square root of 2, all over 20k. The GCF here, guess I did capitals last time, so GCF in this case is 5k. So divide by 5k, divide by 5k, divide by 5k, and we're going to end up having 3. The k's cancel, so that part cancels, 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 cancels. This cancels, this cancels. This goes down to a 4, and this goes down to a 3. So we're going to have 3 plus the square root of 2 over 4. And that is it for section 5.5. I will be, or sorry, 7.5. I will be back with you shortly to do 7.7 and the little bit of 8.2. Thanks, guys, and thank you for sticking with me while I record very late at night.